Hello everyone, it's Mike Levin, Tuesday, July 12th, 2016 at around 9:45 a.m. and I am continuing the tutorial I had begun on dictionary objects, creating this index all the way up to ZZZ in order to be able to address columns in a spreadsheet. So the video that I shot on my walk to work this morning explains the sort of overarching theme of this series of tutorials where I'll be leading up to creating the next iteration of my Pipulate product where you process batch SEO jobs by just submitting requests, basically, where one column is, say, URL and another column is something like page authority, and then you put some sort of URL in here, and then you put a question mark here, and then in the old system you would hit the bookmarklet, which I still have around here, and it would essentially just replace the question mark by feeding this as the argument or the input parameter to a function named this and replace this with the output. Now, as soon as Jupyter Notebook came along, I saw that this was really the preferred user interface for doing this sort of work. So this series of tutorials is leading towards that. And I'll still be doing a lot of interaction with Google Spreadsheets, but it will now generically work against CSV files or Excel files or basically anything Python can interact with. So it could do jobs against Redis and such. And I'm giving you a little preview. Yesterday, I showed you about how list comprehensions, a simple statement like this, can replace a series of lines like this for the better, or for the better. We'll go with for the better. And we put that back into this original program, so now we have a dictionary sitting there. Now this leads to a number of questions that I'd like to answer before we move ahead in the tutorial. I refer to Python as sort of an object shaping environment. It's easy to think of it as a scripting language, very much like Perl or Ruby or Tcl or any of those other ones out there that are really great at just like list processing. Sometimes lists is built into the name of the language, such as Perl and Lisp. But Python has all these pre-shaped objects that have, each one of them has a great story to it. So as you'll remember, if I were to just go type of a dict, it's going to tell me what type of object that is. It's a dictionary. And with the dictionary, that means that all these numeric indexes here are kind of like redundant with a numeric index that you could have gotten off of a much simpler data type, namely a list. So say you were to just throw list around a dict, what would happen? Well, you get the keys out, because whenever you ask for the sequence of a dictionary object without specifying whether you want its keys or its values, you're going to get its keys. So naturally, we can just go like this and not great at this IDE type interface yet, but I guess I can hit enter. There, see? Now, you would think that would be it, but you'll remember the lesson. Whenever you're reaching into a method to actually execute it, you have to put this open close parenthesis. That basically means execute this instead of using a pointer to the object in memory. You want to actually run it. So there is a list of the values, and if you were to say a list equals, now we actually have a list in memory like that, and where we could go a dict and feed in a numeric index like 10, or let's see, I'm Mike, so I'll use my favorite one, and if we were to do that in a list, 13, you'll notice one of the differences between the two approaches. The next one. That's because a list is using a zero-based index again. But in memory, it is more efficient. It's just a list of you know, A through ZZ, a list. There it is. Or if you prefer, get rid of the pretty printing effect of Jupyter Notebook. And there they are right there. It's just a list, no numeric index, because the numeric index is implied in the fact it's a list. Perhaps a more efficient way to go about this. And I might change to that in the actual implementation for looking up the column names from a number. Seems pretty reasonable. But what about the other way around? What if you wanted to feed in one of these and get the number out? Well, you could search for its position in the list, and Python certainly supports that. But even better, why not use this same API to just plug in the letter and get out the number? Well, that gets back to the dictionary project again, and the reason I want to make this video. So let's delete some of these because they will be confusing to look at as I bring you through the next step, which is basically, let's remind you what this looks like. Oops, no, it's a dict that yeah, this is the extra stuff still. Cut, cut, cut. See the confusion. A dict. We have key value pairs. Now, this is almost always a lesson in list comprehensions because almost everything is involved in list comprehension. So first, let's put a pair of square brackets around that and see what happens. Well, now all you have is a dictionary inside a list, and that's not really where we're going. But putting square brackets around something is always a good first step in doing list comprehensions because you then just do X for X in. So if you always just remember that square bracket first trick and then the X for X in as your second trick, you are now in the world of list comprehensions. And as you can see, it's just bringing up the keys because same rules. If you want the values, you got to ask for the values. Okay, this now doesn't look terribly different from what we were doing before, but now that it's a list comprehension, you can do some neat stuff. So, as you'll recall, you can ask for the keys. This would be another way of asking for the keys. And as you just saw, you can ask for the values, but you can also ask for the items. When you ask for the items, you get a list of tuples. Notice those parentheses. Those parentheses are very significant. They mean these are tuple units. So I now just converted it into a list of tuples. And remember tuple unpacking? Tuple unpacking is really awesome because you can say x, well first I'm going to make the mistake, x comma y for x comma y in dict.items, right? So you're unpacking the tuples. But remember these parentheses here. That gives you a little heads up for what the mistake's going to be. Syntax error, invalid syntax. Well, you're going to find that whenever there's ambiguity about what you mean, you have to put the parentheses around your tuple pair. If there's not ambiguity, tuple tricks tend to work with just the comma in between. But if ever you're doing something that you think should work with tuples and it doesn't, look for where you might put parentheses around things for getting rid of ambiguity. Python just tries to work and make everything work just perfectly all the time if there's only one thing you can mean. If there's two things you can mean, it throws an error. So, do you see where this is heading? This is the exciting part. X comma y for x comma y in this list of tuples. Well, what about if we're going to reverse it for reverse lookup, right? We want to plug in H and get out A, plug in KT and get out 306, y comma x for x comma y in adict.items. Bam, list of tuples reversed. Now before I hit the punchline, because I could simply do this, let's see, parenthesis, dict, and call this a finished job, right? Oh, there's the dictionary object. I jumped to the punchline. Let's get rid of this stuff for a second and show show you first our simple reversal. And with list comprehensions, notice these are square brackets on either side. And when you do a list comprehension statement, you get the list out. That all exists in memory right now all together. Now say that dictionary object were, say, a binding to an open file with millions of rows in it. It would indeed try to create the list in memory that existed all at once with that many elements in it, and you could hit memory problems. Well, Python is a wonderful environment where you don't have to load everything in memory right away if you don't have to. So before I jump ahead, I will do one more thing where I'll put, I should have done this when the dict word was there. I just want to show you type. You've got a list. It is a list type. A list comprehension is a list type. Now, let me show you what happens when you change those outer square brackets to parentheses. List comprehensions, but as a tuple, what? Oh, you also got to be careful with highlighting stuff when you do that in Jupyter Notebook because of command line completion. This is a list comprehension with parentheses instead of square brackets. Generator object, what? Well, that generator object means that whatever this represents could be millions of rows, and it would never load it into memory at the same time. Generator objects load line by line, do their thing on that row, and then dump what they just had in memory. It is what many in the SQL world would call a cursor or a forward-only fire hose connection. So that is not the output of what you want. It's one of those pointy bracket things. Well, you could just go dict around it. And so this function call is going to dump the contents of the generator object. And once again, you have your dictionary, your reversed dictionary. So that was just a long way of saying that for memory reasons, it's nice to change these containing brackets from square brackets that force it all to load in memory as a list comprehension into a generator expression. You can see that's where I jumped ahead here for the spoiler. But now I have a reversed dictionary. bdict equals that. So now it's in memory. And bdict square bracket and whatever you want to look at. What is, ZZ? What is that position? 702. What is RT? 48. What is it? ML? 350. So this object that we just created, bdict, and we'll print that so that it doesn't go all vertical on us with a pretty print, now has a lot more reason to exist than the adict object, because the adict object could easily be replaced by a list because you have a very similar numeric index built in for free. But doing the reverse, it's quite worth having a dictionary object because searches on dictionary objects on character or string data types, any immutable data type can be used as a key in a dictionary. So these lookups are blazingly fast, and this object, bdict, is actually probably quite small in memory. So there you have it. This was the story of many things. This is the story of reversing the key value pair matching of a dictionary. This was the story of switching from list comprehension to generator expressions. It's a story of unpacking tuples and knowing to put the parentheses in around certain tuples when you unpack them. It's the story of optimized lookups using immutable data types as keys, and reason to use a dictionary object in a situation where a moment ago it looked like we would have been able to get away with just a list in all cases, but when we need to do that reverse lookup, dictionaries are the way to go. So dictionaries, tuples, and lists. Python is really the story of how these things flow around and become what you need when you need them, with relatively simple expressions that you can cobble together using very simple sequential processes. We're sitting on top of bdict here. Let's just do the final bdict to hit home that process. You first take an object like what you're sitting on here. You can put square brackets around it. It turns it into a just whatever that object is shoved in as the first element of the list. But you can go x for x in. Now you got list comprehension. And then of course what you do next is all dependent on what type of object this is and what you're trying to do. If you wanted to filter this list to only those that began with A, well, you can put that in there where, x, first element in x equals A. Hopefully this will still be a good video and I'm not screwing this up. This is not something I experimented with. Syntax error, where if. Once again, keeping my mistakes intact for your benefit. You can, list comprehensions can do this additional thing that I didn't talk about yet in my videos, which is filtering. So, you start out with your object, you put your square brackets, you put x for x in, and then you can start changing these things, times 2 if you wanted to just see it doubled twice. You can start manipulating things here. You can start putting if statements in as filters in the end. And this really, hits home the point that, this sort of stuff is all about map reduce. This is not only map reduce in one step, this is map reduce filter in one step, this short. And it's map reduce filter where you can change list comprehension if it was against an enormous data set into generator expressions, which you can iterate through and do stuff on to get it right back as a list. This is sort of defeating the purpose, but it gives you the point. Once you're on a generator expression, you can do things outside of it. Probably it makes more sense to do, for item in collection, print item. Now you could step through, objects, things that are loaded off of the file with an open statement that are enormous, and it will still be very light on memory simply because you switched the square brackets to the parentheses to change a list comprehension into a generator expression. Well, that is I think one of my more exciting videos, really pulling together all this wonderful stuff about Python, showing you all the stuff that Python is that people just normally don't think it is. It's not just another scripting language. It is regular expression deluxe. Back in the day, there was something called snowball pattern matching. That's map reduce filter in terse short statements. It's just, manipulating icebergs from your fingertips once you really get into the groove of it. And as you can see, we're just the third tutorial in, and I'm already bringing you to generator expressions, which is in a lot of Python tutorials is an advanced topic. But no, what's really been advanced with what I've shown you? Look how short these statements are. Of course you can do it. Just start thinking in these terms, following my tutorials. And thanks for joining me. Hope to see you again soon. And don't forget to subscribe.